All right, I'm going to try to get through this recording without coughing in anybody's ear. But I wanted to summarize what we talked about in our second day of our discussion on internal controls. So going back to our E360 course, we just want to remind you that this Google Doc is out here. And I'm not going to bother doing that because I already have it open somewhere else. Well, I thought I did. Give me a minute and I will find it again. So this document right here that we've been working on, we have a few new people who have added their input in. So Kyle has added his thoughts, and but really we need to go down. My pyramid kind of disintegrated because apparently we can't insert text boxes in Google Docs. And so instead of the pyramid, it seemed easiest to turn this into a table. So here is our 5 framework pieces right here. We had 3 groups in class today, so 3 of them are filled in. And then they summarized a little more plain English what is going on in each of these. This table is not finished yet, so anyone who was not in class today can come in and help us finish it. So in other words, you have a handout where you have control activities as one of the items, and you have this detail. And then the next item, this one's broken down, sorry. The next one you have is monitoring, and then this was the detail that's in monitoring. And this is what we tried, this stuff here, is what we tried to summarize over here in this table in plain English. Because this gets to be a lot of words here, and it can be hard to remember exactly what we're trying to do in monitoring. The third one, information and communication. The fourth one, here we need somebody who wasn't in class to pick this up and add risk assessment into our document here, and then to summarize in plain English what's going on there. So we need that filled in by somebody. And then the last one, the control environment. And here is the detail of things that go on in the control environment. So we need somebody else to add that to our table. The control environment would be the last one, and summarize in plain English what's going on here. Anyone else who hasn't yet provided any input can also go through and kind of modify these a little bit. If you have a better way to phrase something to maybe summarize in plain English what's really going on here, feel free to do that. Go for it. The point is to help us remember what each of these major framework pieces are all about. All right, so that is going back and just refreshing our memory on the SOSO framework. Let's see, we did this on day 1. I'll skip over that. All right, so the next thing we did is we picked up here with spreadsheet errors, and we opened up this particular example and kind of explored this document a little bit. This document is very indicative of a spreadsheet that you might inherit at work. So someone might create a spreadsheet several years ago, and every year people continue to use this spreadsheet. But it's good to always go back with a little bit of a skeptical mind and analyze whether or not this spreadsheet is even accurate. Should we be using it? Are there fixes that should happen? Because the problem with spreadsheets at work is that everyone uses them, which is great. They're an awesome tool, but there's very little controls that we can put in place on them. So for example, some issues that people found here, let's go to formulas and show formulas, and you can quickly see all the different places that the prior user just typed in numbers that you may have actually expected to be a formula. Price times quantity equals, and you would not have anticipated that they actually typed in the answers here. And that can be dangerous for any future users of a spreadsheet. Same thing over here. These are all typed in. The formulas down here are rather critical because the user individually selected each account instead of using the equals sum and pointing to the entire reference. The advantage of doing an equal sum over individually picking each cell is that as future users come along, if they go and insert a row within a bunch of data, the new numbers will automatically be included in the totals. The way this formula is now, anything new inserted would not be included in the total. So just some rather innocent issues that might come up with a document at work that you inherit from someone else. Something else we looked at are these additional articles that I've put in. The purpose of these is to just remind you that these are ongoing conversations at work by our accountants, by our owners, by our management. So open each one of those and just read them and just kind of look at them as the perspective of, oh, like people are really talking about this stuff and they're really interested in this stuff. We are in our class focusing on the top part of the pyramid here. So IT controls, physical access, locking things down, requiring transactions to get specific authorization. So for example, you are not allowed to order inventory unless you get a signature from someone, or at least unless you've hit a certain minimum threshold, like inventory gets under $1,000 and you are now allowed to buy new inventory. That sort of a thing. Some controls in place. But all of these things, this is where we're spending most of our time in this class, is on these control activities. How can we put controls on ourselves to eliminate possible error and on our other users to eliminate inadvertent or maybe purposeful errors? Okay. Let's see. So one of the ways we do that is by using check digits. So this next item here talks about what is a check digit and how do we create one. But the idea of a check digit basically comes down to, if I type in a number in a computerized system, like a credit card number, how do I know I typed it correctly? What if I'm typing an invoice number or a customer number? How do I know that the number entered is correct? Because over all of this stuff, if you can eliminate the garbage that your users put into the system, then you get better results on the other end. So these things called check digits are a mathematical formula or a mathematical rhyme or reason, a set of rules put in place, and the rules are different based on the game that they're playing. You'll see as you watch these videos that there's like mod 11, mod 10, mod 7. They're all different sets of rules that we play by. And as long as you know the set of rules that are being played, then you can check for the validity of the number. So watch each one of these videos, and even for this one here is testing an ISBN number. Every time you buy a textbook and you are told the ISBN number of the correct textbook that you need. There are actually two different ISBN numbers. One's a 10 and what is the other one, a 13-digit number. But that's a lot of numbers to type into, say, a book system, a library system. How do you make sure that the person entered a valid number? Well, the last digit is a check digit. So get out a textbook, maybe, and I'm in fact going to pull out one of my very own and look on the back for the ISBN numbers. And one of them should be a 10-digit number. That's the one that you could play along with as you listen to this recording and see if in fact it works for you. Then go pull out your own credit card and try this video. So working along with this video, you will find that credit cards follow another set of rules. This third one is a different person doing the same check on credit card digits. This guy approaches it differently, but you'll see how in the end he gets to the same point. Then in class, we split up in groups and each group learned one of these, except for this one didn't work anymore, so I need to delete this third one here. But for those who weren't in class, you'll have to look at each one of these and just learn a little bit about it. I'm just trying to get you to see different methodologies, different sets of rules to the game that are being played here. Then finally, here's a couple more additional ones. If these weren't clear, you're still left with a few questions, or if you're just curious, these are some additional resources you can go to. Go do this IQ test, fraud IQ test again sometime. This one is linked directly to the Journal of Accountancy. So that one will give you an idea of how you can spot fraud. And then we get to my assignment, which is making a check digit and using a check digit. Those are the first two items indicated here in this assignment due November 13th. We have not yet talked about the last two items. So the make one is a $500 assignment, and then the use one is a $750 assignment. Don't continue with this video until you've done this check digit project here, because you need that background before you can continue this conversation. So stop it and go do this piece. Then come back to this video and pick it up from here. So moving on to my example, you're going to have to make one. So here is me making one. You can kind of see how I did it. This one is using Mod 7 rules, so it's just a different set of rules. The rules in this case are take the number you have, whatever the number is, and divide it by 7. In this case, I picked the number 11, divided it by 7, and I get 1.571428. Well, you take the first digit after the decimal, so the 0.5, and you multiply that by 7, and you get an answer of 3.5. And you round that up to the nearest whole number, so 4 would be our check digit. So this is just a system, a methodology, a set of rules that everyone is going to do. So if you tell someone, I'm using Mod 7, they automatically know, oh, I'm going to take the first however many digits, just exclude the last digit, divide it by 7, and then do the first number after the decimal, multiply it by 7. You're going to follow this exact methodology, and you should get their last digit in their number. Now, we're not going to do this one step at a time painfully every single time we're trying to see if a number is valid. Excel can do this for us. So here's an example of an account number. We might assign account numbers to our customers. So we have a 1, 2, 3, 4, 5-digit number that we create. And in the end, our goal is to have a 6-digit number. The 6th number will be a check digit based solely on the first 5 digits. And if you use Excel, you can just tell Excel, hey, go use the Mod 7 rules on this number over here. And so Excel is dutifully going to do all of these steps for you. You don't have to do any of it. And Excel is going to come back and go 4. Let's double check this and see if this works. 2873 divided by 7 is a really lovely number. And I'm going to take the 0.4, which is the first digit after the decimal, multiply it by 7, and get 2.8. Uh-oh. And rounding that up to the next whole number would be 3, not 4. So what in the world? Oh, ha! I thought I used the 9 as a check digit. The 9's not a check digit. I don't have a check digit yet. So it's 0.5 times 7. There we go. And round that up to the nearest whole number, and that's a 4. So the 4 is our check digit. We need to add it to the first digits of our number to create one big long number. I used concatenate here to bring together the original 5 digits and add the 6th digit onto the end of it. Okay? Let me clean this up a little bit. Alright, so that's my example of making one. This would be my customer number right here. And as my user uses the customer number over the next few years, if they ever mistype anything in here, hopefully they would get an error message because the system would constantly do a mod check to see if everything looks on the up and up. Now, the system checking it is where we're going next, the use one. So here's the top of an invoice, and our customers, every time they create a new invoice, they're going to enter the customer number. And if they enter a number that's not valid, here's my 6-digit number. If they enter a number that's not valid, you would like them to somehow get a visual, an error message or something telling them, hey, we think you goofed up. We don't think this customer number exists. So for example, if I type a 6-digit number, well, it happens to be correct. Let me try another one. Ha, that one doesn't work. Okay, so somewhere in the background it did some evaluation and said, we don't think that's right. You goofed up somewhere. Because if this was a valid number, 99988 would have been the original. That's the first 5-digit number. Mod 7 rules divided it by 7. Oh, huh. There is no decimal. So 0 times 7 would have been 0, so I guess we would have expected this last digit to be 0, which means the user entered an invalid number. It may have been that the last digit is wrong, but it may have been any one of these other digits that they typed wrong and goofed it up. So let me change this back to a valid number, which I gave myself a few examples as a reference. There, that one's valid. So how did I get Excel to do this? Because notice right here, your user is going to come and they're just going to type a number in. So I can't type a formula in this cell. Then I'd be using the cell and then they wouldn't be allowed to enter a number in here. So this has to be available for them to use. Now you can use data validation to do some kind of a check, but in the end, what is that some kind of a check that you need Excel to do? I hid mine on a sheet that my user, oops, I don't want to actually hide, unhide. I hid a little side calculation somewhere where my user wasn't going to see it. So what did I do? I asked Excel to hey, go look at the number that the user entered. And so that number is coming in here. And I'm not quite sure. I'm kind of curious as to, I was going to look this up earlier. Oh, all of this, example dash, okay, that is the name of the sheet there. And I'm pulling B17. So that is the number that was entered over here. That's all I did. I said equals that number. Okay. Then I said, all right, Excel, looking at the first 5 digits, what should the check number be? So I had to pull the first 5 digits. So starting from the left, I needed 5 digits. And then I needed it to calculate mod 7 on that. And it came back and said 1. 1 should be the check digit. It should be the last digit that the user entered. Well, visually you can look at it and go, yeah, that is exactly what they entered. We're good to go. But that doesn't help us in the long run because visually we can recognize that, but we need Excel to do a little analysis and decide if it equals. And so I had to say, well, hey, Excel, if the number that's in here equals that last number here, then give me a good message. And then if it's not, if the number here does not equal that number, that's the if false, then tell me error. And so that's how I let Excel decide, hey, do these two numbers here equal? So great, now Excel knows if it's good or bad. Now I need to figure out how to tell my user that they made an issue or not. I did conditional formatting. It's not the only way to do it. I would like to see some people try doing data validation. But here all I had to do was say, hey, this cell, nope, not that cell, this cell over here, which I can't go to at the moment. Oh, this worksheet. Nope. All right. This one right here, cell C3. If it says error, then I needed the user to see a big, ugly red color. And so that's why over here, if I type in a bad number, over here, Excel pulled the number over, did its own calculation and said, should have been 4. Said, well, 4 does not equal 8, so we have an error, and came back over here and gave me a red color. So this at least would tell the user, we have a problem. Now, instead of doing a conditional formatting, I really would like to see somebody try doing it under a data validation where you use a formula, but that would be bonus. That would be token money. All right, I've got someone at the door, so I need to go. Email me if you have any questions.